Let's talk about how coordinate points are related to functions again. And an easy way to think about it is just looking at the function on a graph. That's one of the advantages of graphs. It might be a little more difficult to think about it in terms of an equation if you're not used to that, but we'll go through that too. So first on the left over here, let's talk about this guy. If I ask, is this coordinate point right here part of the graph? What you do is you look at the x-coordinate, which is the first number right there. You go to the x-coordinate, so that's 2. That means 2 to the right. And then you go in the direction of the y-coordinate also, up or down. So this case is -1, so that's down by 1. So you can see where this is pointing me. It's somewhere like right here, and that is clearly not on the graph. So that'll be a no. But if we try another point, let's say this one right here, that says go 0 in x. So we don't go left or right, we just stay right at the middle. And then we go up 3. So it's going to lead you right up to about here. And if you plot a point there, you can see that is right on the graph. So in this case, it would be yes. So just walk through these things and say whether the point is on the graph or not by looking at the picture. Now in the equation form, it's not quite as straightforward as that, but it's not too bad. Let's take a look at this equation. See, instead of a graph, we're given an equation, which when you get good at them is really just as good. Sometimes it's actually better. We're going to take each of these points and plug them into the equation. And here's the way that's going to happen. Let's talk about that first one. -6, -4. So I plug this in. And the way that I do that is I say f of, and now all the x's I turn into -6. So f of -6. And if I do it on the left, I'm going to do it on the right also. So this becomes, instead of -x squared, it becomes -6 squared. Minus 2 times, you guessed it, -6 plus 2. Okay, so this is called evaluating an equation or evaluating a function at a point. And now we work through what happens here. So this is negative times 36 minus 2. Well, I'll just write it out and we'll simplify a little more in each step. So there's my first step where I got rid of the exponent. And now I'm going to get rid of the parentheses through distribution. And I see this is -36 plus 12 plus 2. And that gives me what? Math. -24. I think this is something like -22. Now, whether it's -22 or -20, or I made some little math mistake, possible, but it's certainly not -4. I wasn't off by that much. So you can see this point is not going to be on the function because the x and the y coordinates don't agree with each other. They don't satisfy that equation. So let's try another one. How about, let's see, hard to do this stuff in your head, but let's try 2, -2. Try this one next. So f of 2 equals, and I'm going to plug in 2 for all the x's. Let's see, this is -2 times 2 plus 2. A lot of 2's in this one. So I simplify this out and I get -4 minus 4 plus 2 equals -6. Well, again, that does not match the y-coordinate on this one. So that's another no, 2 no's in a row. Let's try this one. -3. F of -3. I mean, odds are one of these things is going to be on the function. So negative times -3 squared minus 2 times -3 plus 2. And then I work this out and I'm going to get -9. I'm starting to move a little fast with the algebra because I'm getting impatient. I want to find something. And in this case, it looks like I've got -1. Now remember, that's the y value. So this means x of -3, y of -1. And in this case, it's a match. So I got 1. This is part of the function. So you can see the algebra, sometimes it takes a little more hassle to work through the algebra than the graph, but if you think about it as coordinate points, all we're doing is plugging in x, evaluating y. That's the way to work through this problem.